So my background, I guess I should tell you a little bit about my background. So I'm a professor at UCCS. I've done 3 significant startups, each of which earned more than 7 million in revenue, and then a bunch of things I've been involved in where I learned things, but we didn't really make much money. But along the way, I got very interested in innovation and entrepreneurship, and so I founded the Bachelor of Innovation family of degrees at UCCS, in part because I couldn't hire people with the skills I wanted in my own company. So I've gone through lots of product iteration. My first company was VC backed. My second company was angel backed. My third company was entirely bootstrapped. We actually got offers from VCs and angels, but we decided to not take their money and just grow through revenue. And along the way, I learned a lot about lean and products, lean products processes. And much of the lean movement is really about the lexicon and how it helps you better communicate. And over the years, I've been teaching within the BI. I've actually learned that this term MVP often creates more confusion and sometimes more contention than any others. And what I'm going to talk about today, what I call MOVE, is really to address some of those issues and give you a better pathway forward. So an MVP is supposed to be, its name is minimal viable product. It reduces risk, maximizes success, faster feedback, reduce overhead, measurable progress. These are all the kinds of things that people talk about why they want an MVP. So Eric Reeves, who's really the founder of Lean and really the first guy to define MVP in a more formal way, views it as a version of product that allows the team to collect the maximum amount of validated learning about customers with the least effort. And this is for a particular one, is from a later version, but he's used pretty much the same definition. So Eric's range of things go from a viable product all the way down to an iPhone without cut and paste, down to a landing page with buy it now. And I'll go through those examples in just a second. And he describes it as the first product might be a landing page about, or a positioning where you try and get people to test it. So, and this is at best what you might call a marketing product, if it's a viable product at all. It's really just a way of testing hypotheses. And so the way you want to look at a minimal viable product is not necessarily to look at it from the product point of view, like where I have a model of, no, that's not a viable car, that's not a viable car, that's not a viable car, that's finally a viable car, to viewing it as a problem solution, which is transportation, where I might start with lower modes of transportation, going to bikes, motorcycles, and cars. So that's a different way of getting there. In each case, you're answering a different question. So a lot of what makes something a minimal viable product isn't really about, is it a product, but what are the questions you want to answer? Okay, so a minimal viable product's name suggests that it would really be sort of in the middle. It's minimum and viable. If it doesn't meet minimal, it's really a crappy product that no one wants. Viable means products that are built by better and faster companies. So minimal viable would be something good in the middle. The problem is that's actually not a realistic way of looking at them. That's not what a minimal viable product is either. So the Quick MVP, this is literally a website you can go to called Quick MVP, or at least used to. And it basically does a landing page plus some Google ads, and then you want to test and use this as a hypothesis test. So how many of you think this is actually a viable MVP? So we got a couple. So, and whether or not, so is this your product? No, so it's clearly not a product, right? So then why do we call it a minimum viable product, right? This is actually about formally testing hypothesis. And I think if we move away from the product concept to an experimental concept, we can actually do something better, right? So Eric's definition of version of product that maximizes learning by delivering and capturing customer value for the least amount of effort. With this definition, the previous thing is not a product or an MVP, because it's not delivering and capturing customer value. It's having them click on a web page is not really delivering value to them. You might capture some information, but it's not really about valuing. So it comes back to that question which I already started asking. So the other problem with it is you may or may not capture some value. That depends on if you're building a mailing list so you can contact them later. But it's really hard to design that landing page to really test your product. It definitely doesn't maximize validated learning because you don't actually get much information out of it. If you have a sign up now button, you got that they signed up, but you don't know what made them sign up. And we're going to go through some of that hypothesis stuff in a second. So, Steve Blank also defines minimum viable product. He's a faculty at Berkeley, very big in the lean and startup space. He defines it as a minimum set of features But I found that as I've gone through this with lots of people, that many founders, in terms of an actual product, act like minimum is part of the goal. And really, it isn't, right? Minimum is part of how they define things. You really want to have minimum in the definition because you want to reduce the amount of wasted engineering hours, code left on the floor. But if a feature takes you 5 minutes to add, then it doesn't, and it adds value to your customer, then it's really not hours of engineering wasted. And so you want to get the product out as quickly as possible, but with a balance of what's minimum and what's going to get you to learn. And we'll come back to that in a bit, because in fact, many good MVPs, if you want to think of them that way, have a lot of features that are not necessary for the customer because they're necessary for the experimentation you're trying to do. So if I actually go back to Eric Ries's definition and look at it formally, it's a two objective optimization function: maximize and least, right? With inconsistent units, maximize learning with least effort. And that space really doesn't make a lot of sense to try and optimize over from a formal sense, because I'm trying to optimize learning while minimizing. So how much is 1 unit of effort compared to 1 unit of learning? Those two are not really comparable. So you really have to look at this in terms of balancing what you can afford to maximize the amount of learning you're going to get. And there's a trade-off in this space, but there's no easy way to look at those. So actually, I'm going to skip over these. So some things that an MVP definitely is not. It is not a focus group, right? By the definition they do it. It's not sitting around with a bunch of people and showing them your product. It's not a software model of early releases that you do very frequently. That may be part of the lean process, but it's not what an MVP is about. An MVP is not about maximizing the chance of a successful model. It may help you do that if you actually maximize your learning well, but it's not just about making sure when I release this product, it's going to be successful, because in fact, that's often generally leads to things with way more features than you need. Right? So we want to focus on the experiments. We'll come to in a second. And then one thing is that, and I see this a lot, it's never a one-sided test in a multi-sided market. So how many people know what a multi-sided market is? Okay, so I'll give you a quick definition. Lee faces this problem. Lee has 2 different markets. He has the advertisers, or at least he did in his older business model, that we're trying to, that we're going to help pay for trough, or the restaurants that we're going to help pay for trough. And then there's the actual people who use the product. Google is a multi-sided market. There's the people who use Google, and then there's the people who pay Google. And those are 2 different groups of people with 2 different objectives. And so you have to be very careful in designing tests for a multi-sided market, because I might design a product that advertisers love and customers hate, right? But if I only test the average, go ahead.
Can B to B to C work like that?
So B to B to C, so you mean I'm selling it to someone who's then going to sell it to the customer?
Yes.
And so that's actually a pass-through market, which is not formally multi-sided. If you can convince the B that you're doing a partnership with, and they have the marketing cloud to get it out to the clients, it's not your problem. But it's really hard to break into that market unless you've already demonstrated the customer demand and draw, right? Unless maybe the other B player gets it instantly because it's like so matched to their portfolio, they view it as something they can sell along their other products. So it may or may not fit in. That depends on exactly how you're positioning it. But if you're counting on customer pull-through, then it effectively is a B to C market, is multi-sided, because you have to sell to both the customers, consumers, and the business.
Got it.
So hypothesis testing in those kinds of markets are much more complicated because you really want to measure these things simultaneously. If I do an experiment that measures one side of the market and not another, it's really hard to get good answers. And we'll talk a little bit more about that as we go through an example a little bit. So then another thing I saw as I've helped students go through this process is what happens after I have an MVP? And I've had lots of students who've gone through this. So how many of you have built an MVP in your company and validated it already? Lee, maybe? Okay, I can't see everybody. So Lou, okay, so Lou, what's next for you now that you've got your MVP? What's the next step?
Getting customers, getting paying customers. So yeah, I mean, we're refining that as well. We've gotten features and functions that we're adding. So it's kind of like also trying some MVPs for other products on the platform. We have a mobile technology platform that streamlines traffic and navigation and crowd management. That's the space that we've been in on a services side, and now we're transitioning into software. And so yeah, so that's kind of where we're at on that.
Okay, so and Lee, what was next after your MVP launched?
Our biggest thing is when we did kind of our first MVP, it was just kind of validating our first hypothesis. But one thing you brought up was the multi-sided market. And that's actually one of the big things we've learned so far going through the accelerator is there's some work we got to do with restaurants because they're kind of the ones paying us. So right now, what we're actually focusing on is meeting with restaurant owners to actually kind of work on that. But I think the next step is once we have that figured out, would be getting users and restaurants, kind of focusing on both sides of the market.
Mm-hmm. Okay, so, and this is not very inconsistent with either of those answers, although Lee's was a little deeper, which is, they built the MVP, they learned from it, and now the idea is validated, it's time to go raise money and build a real product. And that's often what I've seen from student teams as they go through this process is, okay, we validated it. Lee's answer was a little better because as part of the validation, they recognized there's more learning they have to do. And I think that's actually one of the problems that I've learned as we try and teach this, which is, I think the MVP terminology actually added to people's confusion because they view it as, okay, we have a minimum viable product, right? We have something, as opposed to we've run some experiments to learn things, and here's our long list of things we have to learn, and we have to keep learning to answer all these questions. Now, you don't necessarily learn everything and then start, right? The idea of iterative learning and building the product out there is great. So Lou's idea of getting customers and learning from those customers. Learning from customers, like from my experience, is by far the best way to learn, right? And in that sense, the minimum viable product is actually useful if it's a product, because every time you put it out there as a product and you get customer interactions and you measure some stuff, you're going to get some value add. But at that time, it may not be minimal, but it definitely has to be viable if you're going to get customers to go on. So early on, it's really not about your ideas, but what's it going to take to execute that idea? What is it going to take them to happen? And so a lot of students, this is quite common, which is like without investment, they can't do anything. And many of you are in the incubator, you all want money, right? And that's a common place to be. Personally, my view is your ideas are worthless if you don't figure out what your next move is. And if you can go through a whole bunch of validated learning very cheaply, then you'll be in a much better position to attract that investment. Or, as I found in my last company, if I do that fast enough and well enough, I don't need investment. I have customers. Right? And if I have enough customers and I can keep growing and building and iterating with customer revenue, then I never need to take on investment. I don't have to dilute my company and take on any other investors. So this idea of how to go there and how to test your ideas is what I'm going to spend the rest of this time on. So again, this is actually a slide from I think you want to see Blank's videos about minimum viable products. Building the wrong product is absolutely an important thing. And I've gone through this in some very expensive and personal lessons. In my last company, one of the products we built to prove what we thought was the minimum viable product, we actually built the product only to find out that it didn't satisfy the multi-sided market requirements. The people we talked to, and ours was actually a three-sided market. There were government agencies that had to approve these kinds of products, end customers, and then sort of public consumer advocacy groups. Two of the three groups loved what we were doing, and the government didn't like it at all, right? And without their approval, it wasn't going to go anywhere because almost every major government installation was needed. So we should have spent more time early on trying to validate all of the critical hypotheses before we built anything. So in one sense, it's often not minimal, not viable, and not a product. In the beginning, most of your cheap experiments are not those three, right? It might be minimal, but or at least low cost, but it isn't going to be viable and it isn't going to be a product. So this brings me to the terminology I like to use in my class, which is minimal objective viability experiment. And that's where we're going to spend the rest of our time. So one of the classic definitions of a startup is a search for a viable business model. You start off with some best guess of your model. By the way, can you guys see my mouse? Okay.
Yeah, we can.
So you have some best guess of your model. You run some experiments. You do some evaluation and analysis. You get some insights and attribution of what caused things. You update your model and you iterate, okay? And there's a common question, so how do you prove your business model works? So who can answer that? How do you prove that your business model works?
I guess an easy way would be to generate money from it.
Yeah, so, well, in the end, it has to generate enough money to be sustainable and profitable, right? So you can generate money, but if it's costing you more to generate that money, and this is true, unfortunately, for lots of businesses in the beginning, they're burning cash faster than they're bringing in. Even if they have revenue, their goal is to grow fast enough. So you have to be very careful how you want to define if it's working. So if first you have some early hypothesis test, is the idea worth pursuing? Okay, and that's where you go through this sort of what we call the customer discovery and customer validation process. And this, you don't, until you've gone through this and you have some very basic validation, you don't really want to start going down to customer creation and customer company building, because these two take a lot more time and money. So in this customer discovery, customer validation, in my view, you can generate a whole bunch of hypotheses, and you should. And the first way you should test those hypotheses is actually not an experiment. In the world of experimentation, we've learned that very often before I can do a real experiment, I often have to do what we'll call a pilot experiment, or sometimes just a data analysis, where we want to look at data to help validate what's the right way of forming a hypothesis. When we get to hypotheses in just a second, we'll see that. So, and assuming some of you have gone through various types of this process, right? What's the primary way of doing customer discovery and customer validation if it's not actually running an experiment? What do you start with? You've probably all done this on a startup weekend or something. The simplest pre-experiment or pilot type of stuff is to actually do a bunch of customer interviews where you start with your hypothesis, you go out and you talk to people. And this is actually a good example related to our experimental process. How I do my interviews is often very critical, because if I ask leading questions, I will get bad answers. And the whole reason we actually do pilot experiments, and the reason we do data analysis before we do an experiment, which is the same reason we do these interviews here, is because doing the experiment is expensive enough that I don't want to get it wrong by asking the wrong questions that bias the results. And we'll come back to that. So our real goal is to minimize the time through the loop of get us some ideas, build something, made some code if you're in my space, measure stuff, get some data, and learn. And as I go through this loop, we want to minimize the total time through this loop until we have a successful product we can begin to charge customers for. And then I want to keep minimizing that until we have a very viable business. So what we really want to do is calculate our moves to really figure out how to reduce our risk. And so this is the first thing that I like to talk about in terms of designing your experimental plan. In this case, even your interview plan. And I see students avoid this all the time. They don't try and answer the most risky questions. They answer the easy questions, the ones that are easy to answer, right? So risk assessment starts by saying, what is the biggest risk to our venture? And if the answer to that is that the competition kills us, then you wanted to figure out how to have an experiment that answers that question. If the most risky question is there a customer at all for our product? Then you want to design an experiment that answers that. So good experimental design sits down and figures out what are the biggest risks, right? So if it's a B to B to C play, as Lou was describing, right, then you have to figure out where is the risk, selling to the business or the end customer is not wanting the product? Or is there another risk you haven't even seen? So early on in this sort of iterating of your hypotheses, you want to not just come up with a bunch of hypotheses, you want to take a look and figure out what is the risk to your business. And then you want to do a little bit more planning and sort of figure out what is it going to cost us to answer that question. So a minimal objective viability experiment is really about the validated learning about the viability of one or more of your hypotheses. And then I view a startup as a sequence of moves and pivots yielding learning about improving an iterative sequence of product services that you offer to your customers. So as I go through these hypotheses, in the beginning, I'm not even ready to have a customer. Hopefully by now, since you're all in the incubator, right, you've all gone through a good bit of this, but you might not have been very consistent or formal in your process. How many of you actually have a formal list of hypotheses? Anyone writing them down? Okay, so this is common and also somewhat problematic. If you don't write down all your hypotheses, you are easily going to fall in the trap of forgetting them in terms of a selective memory. You forget about the ones that you don't feel comfortable about, and you focus on the ones you feel more comfortable about, which is often testing the things that are easy to test or that make you feel good about your product. And that's where you get into bad risks. So when I lost $1 million in my last company, building a product that we could not sell in the beginning, it's because I talked to the kinds of customers, the visionary customers that people often talk about as what you're designing your MVP for. That's what all the reading had taught me. And I quickly found out that that's okay if those customers are also the decision makers and the users. But as soon as your market has multiple players in it, different decision makers, different customers versus payers, you've got to validate that the people who regulate the market, if that's a market you're in, aren't going to stop you, or that the people who are paying aren't going to pay even if the customers love it. And you can take this model that, after we get 1 million customers, they will pay. Well, getting to 1 million customers is a big hypothesis to test. Right? It's a lot of money to get there to find out whether or not at that point they will pay you or not. So you got to figure out how to make these sequences in a more effective way. So some advantages of looking at this from a bunch of moves and of formalizing your process is there's no pretense that it's about a product. A lot of your hypotheses are not about your product. They're about the market, the competition, and other things. And so there's no pretense it's actually a viable product. You want to focus on an experiment about viability. And there are multiple hypotheses, and there are many potential things you can do, right? And your team's got to figure out how to balance the learning and their cost. And by viewing them as formal hypotheses and writing them all down, you can often tweak an experiment to get an answer to 2 or 3 hypotheses at the same time, as opposed to focusing on just one. So not only does writing them down allow you to make sure you remember them all, but it allows you to sort of say, oh, could we answer these 2 at the same time? And then for your company, part of what you want out of all of this is also your internal communication among your team members, as well as your communication with advisors, investors, and everything, and everyone else. And if you define things as a very formal sequence of moves with hypotheses to be tested and various pivots, it becomes an easier story for people to remember, and also to not get locked up on calling this my minimum viable product or anything else, because this is an experiment to test this hypothesis. Does not convey that this product has to work completely. Otherwise, what often happens is you show your MVP to an investor and they're like, oh, but what about A, B, and C, which are things they think is important, but that's not what you were trying to test. And it gets lost in their idea of what they would want in the product, as opposed to being clear about here's our hypothesis and here's what we're going to use to test it. So viable and viability are actually related words, right? Viable, though, is capable of working. It describes a product that is least useful to customers. Testing a product that is viable requires testing the product is actually working, whereas viability is capable of becoming practical and useful. And in fact, that doesn't have to be about the product at all. It can be a statement about investments. It can be a statement about competition, right? But that information becomes practical and useful because it's helping you validate where you're trying to go with your company. An idea may be viable while the current product is not, okay? And more importantly, ideas may be viable, may be tested for viability without ever getting near having a product. And interviews can actually be a way of testing viability. But it's important that we also, in the definition of move, also talked about an objective experiment. So what do I mean by that? So first of all, and this is the one I have the most problem getting my students to understand, and even some investors, experiments can only reject hypotheses. There is no experiment that will prove a statement is true. All you can ever do with an experiment is prove a statement is false. Does anyone know the reason for that? Anyone here actually study enough science to know why we talk about falsifiability in science? Okay, the reason is actually pretty straightforward if you think about it. In the infinite world, right? Let's say that I say something is true. Well, if I say something is true, I've only tested a small sample of the world. So I don't know if it'll be true forever, right? If the statement can be proven false, then I have some way of actually rejecting that hypothesis. And very often we end up going through this process we call rejecting the null hypothesis. And some people will say that means they accept the hypothesis. And so from a very informal point of view, people will say this experiment proves this thing. But they do that through effectively a double negation. They define the hypothesis to often be inversion of what they want, and then they prove that the inversion is not what they want. And they accepting it as sort of saying, well, if it's not A, then it must be A. Well, in an infinite world, that actually is not true, right? There may be other ways. If the possibility or A's for A is true, false, and maybe, then not being not A means either maybe or true, not necessarily true. So you have to look at things in a broader sense to figure out where this is going to go. So this is by far the hardest thing I think people have to do. So I thought we'd go through an example here. So let's say that at a certain level, and this is probably something that all of you face, you want to estimate the size of your customer segment. Okay, is that a falsifiable or testable hypothesis?
I'd say no, it's not.
Why not?
That's I mean, subjective. You can't refute, estimating the size of a customer segment. You need to say it needs to be built in a manner where the hypothesis states the customer segment is less than 1,000 people or something to that effect.
Right. So
open-ended is not enough.
Because it doesn't actually have a hypothesis, right? Our goal is to estimate the size of a customer hypothesis. To turn that into a testable hypothesis, we have to define our customer segment. So we might say that among people between the ages of 20 and 35, no less than 25% of them will be interested in our product, right? Now, if I sample 1,000 people, can I show that not less than 25% of them are interested in the product? Yes, I can. Slightly better would be to formulate it that not more than 25% are, and then to actually reject that hypothesis. Because it turns out to be doing formal hypothesis testing. It's easy to run an experiment and then ask the question, and there are formal tools called like a t-test to test the hypothesis, given a customer size and some measurements to figure out where that is. I'm not going to go into all of that, the details of the statistics stuff today. Actually, I have some talks and stuff on YouTube. If you're interested, I can send you links, but I teach them in one of my other classes. But the first thing is to be very precise about what it is. So first you have to define the customer segment, and then what's the number you expect it to be. And if I go out and I say it's at least 25%, and I measure it's 26%, can I actually say it's 25%? I measured 26.
Sure, why not?
Echo says yes.
So you can, but you probably need more information. If I actually measured this out of, so I guess to get to 26, I need, I don't know, maybe 20 people, and then some fraction of those is 26, right? So if I measured, I'll do 25 because it's easier, right? So I can do the math in my head, right? So if I measured, right, out of 20 people and 4 of them, 25, so it's a quarter, so 5, right, of 20, right? If 5 of those people said, then I'd say I've met it. But 20 people is not a very big sample. If I got 25% out of 1,000 people, I could be pretty confident I was there, right? And so when we look at hypothesis testing, a very important question, I guess I'll come back. I must not have finished the slide. A very important question is sort of what's the error bound? If I actually only sampled 20 people, the error that I could expect is around plus or minus 10%. So if I measured 25, well, it could easily be 15, it could be 35, right? It's not 5, however, right? It's statistically not likely to be 5. So this is why we have this idea of a probability of P of 0.05, right? So I can define a confidence interval, and any statistical test will go through and give you some of those numbers if you formulate them right. But the second thing that I have to be very careful about is when is an experiment objective, right? So all measurements, all feedback is not the same. And so we have to break our things into looking at things in terms of subjective and objective measurements. Asking people what they think, like, feel, or desire is always subjective. It doesn't matter if I get a number out of it. On a scale of 1 to 10, how much do you like this product is still a subjective measurement, not an objective measurement. Why? Because you're asking them what they think. And when you ask people what they think, they often lie. Sometimes it's intentional because they're your friends, and sometimes it's unintentional because they want to look good socially. So the fight from polling point of view of asking people who they're going to vote for, right? There's this whole background discussion of this idea of a shy Trump voter who won't admit publicly that they want to vote for Trump, or depending on who they're out with, right, they won't admit they want to vote for Biden, right? Because social context affects how we answer these questions. And so asking people what they like, think, and feel is always subjective. It also turns out it's very much a function of how you ask that question, when and where. So those would make it so difficult. Measuring behavior is often considered a more objective measurement, but it also depends on how I'm measuring it, and again, in what context. If I actually ask people to do things in front of their friends, I still get the social effect, and therefore I get a less objective measure than if I'm asking them in more isolation. This is one of the reasons why when we talk about doing customer interviews or customer experiments, unless your experience is expected to be a group experience, which Lee actually has to deal with, right? You're looking at people going out to dinner together, then you might have to consider group experiments. But if it's an isolated purchasing decision, then you should be testing in isolation. So you want your experiment, if you're going to measure behavior, to be as close to the operational environment as you can. We talk about designing potential size and power of the experimental design. So a first rule of thumb is if you haven't measured more than 30 things, you probably are not in a good position. And in practice, it's more like 100, because the variance you will get from measuring across people is so large that you need around 100 to get an answer to be within plus or minus 5%. And that's the kind of number you're often looking for. Now, if you're willing to live with, I measured something and I could be off by 30%, well, then you can live with 25 to 30 samples, right? But you got to dig deeper to get where that is. And the answers to how far you go down that path are very dependent on the questions you're asking. So if you're designing an objective experiment, one of the critical things is that you formulate your hypothesis and the test of what will be learned before the experiment. I've seen way too many students and companies who say this is a hypothesis, but they formulated the hypothesis after they gathered the data. And if I torture the data long enough, it will tell me anything, right? The goal is not to go out and collect a bunch of data from interviews and then go back and say, see, this supports our hypothesis. You collect the data from experiments, from interviews, to formulate better hypotheses. And then you go out and test them, right? You really don't want to be trying to use the data you collected before you had the hypothesis, because you'll just fit the data, which is overfitting and causes you lots of problems. So when you design these hypotheses, you want to figure out who and what is being measured and how are you measuring it? And these are probably the three most important questions. Who, what, and how am I measuring things? If you don't have a metric, if you don't know what you're measuring, you're not actually testing a hypothesis. You're doing interviews, you're gathering data. That's still useful stuff, but don't convince yourself that you're testing a hypothesis if you're not very clear about the metric that's being measured and set out up front. Here's our metric and here's how we're going to measure it. Now, if your hypothesis turns out to be false, you will generate a new one. And that might be based on new data. And guess what? If you do it, you go out and you measure it again. You don't just say, well, the data showed us this, that's our new answer. You have to iterate through this process. And so this is the iteration of hypothesis that's sort of the core of what we're talking about here. Every time you do a measurement, you can go out and gather new data. And so you need to go out and gather new data. Okay. It's also really important to understand the distinction in early experiments between the idea you're trying to test and your ability to communicate that idea and how you're going to differentiate it. So one of the problems with a landing page test that lots of people like to do is that when you run one of those, right, a lot of it will depend on how slick is the graphic you literally use to display your product. If your product looks more finished and polished, or if there's no product at all, but there's some cool looking image that gathers people's attention, then that might actually pique their interest and get them to give you your name because you've intrigued them. Not because they like what you're doing, but because it was intriguing. It was a curious question or an image that I related to somehow. And that may or may not relate to your product. Okay. Is the hypothesis you're testing about the customer segment or how you're going to reach that customer segment? So if I do a Google AdWords search trying to send people to my landing page. What have I assumed about my customer segment? There's actually a critical hypothesis for that experiment.
They're on Google.
They're on Google. Well, that's, yeah, but there's actually something much deeper than that.
They're
You're-
searching for something like your product.
Yeah, they're searching for something like your product, which means your product has to be something in the space where you can generate search terms that are relevant enough. If you choose search terms that are too broad, they're not really looking for your product, they're looking for something else, right? Or not really appropriate. And that's what often makes it really hard to do that MVP of a landing page and really get validated learning out of it, because there's these questions. Is it the idea, the communication of the idea, how you reach those customers, who the customers are? It's really hard to gather great data out of that stuff. You can get data. Now, if you want to build a mailing list, I highly recommend a landing page, because if your goal is to get emails, if my hypothesis is, can I get 100 emails to send people information about my product, then you can test that hypothesis. And if you can't find keywords that will help you find people, you're problematic, right? But there's a different approach. Maybe it isn't, you do it on keywords, maybe you do it on Facebook ads, right? Because now you get to choose a different way of defining your customer segment and reaching them. Now you've assumed they're on Facebook, and you've assumed that you can demographically describe them in such a way, has nothing to do with their search terms. It has to do with their age, their gender, what else they have interest in. And so there's a little bit of interests, but that's not the same as the search terms are used. Very different hypotheses, right? Both of which can lead to a landing page. If your goal is a landing page and collect emails, great. If not, you got to be careful in designing those experiments. So some of the most common experimental failures, and by far the first one most common one I see, is bias sampling and inducement. And this is a problem that is so easy to overlook. I probably fall into this trap at least once every other year. And I've been teaching this for a decade, and I still fall into this trap, which is I design an experiment, and in designing the experiment, I forget that I am forcing a bias in my sampling. So we already had this example for like using Google AdWords. But even if I decided that I was doing that, if I do something like offer people a free chance to win something for signing up for my product, or so signing up to be emailed when my product launches on Kickstarter, which is the example I had last year when we failed. The problem is that inducement changes people's behaviors. They're no longer telling me anything about their real interest in my product. They're telling me about their interest in whatever I'm giving away as a raffle for free. So if I'm going to give away an iPod and my product has nothing to do with an iPod, then I'm actually really distorting my experiment by getting people's incentive unrelated to what my product is. And this is by far the most common problem I see, is a combination of inducement causing all kinds of bias. And even if I don't have an inducement, if I really just have an experiment where I invite people to use my product for free, I still might have a very biased sampling if the way I'm advertising to get that out is itself biased. So if I'm looking at this and I'm saying I'm going to advertise on Facebook, but my product is really aimed at IT professionals, I might not be reaching the right market segment, right? Because that might not be the best way to reach those people. So when I define my formal hypothesis, I want to say, here's my customers. And this is why, again, interviews are so helpful in the beginning. I can figure out, if this is my customer, where do they spend their time? Where do they spend their time online? Where do they spend their time in person, right? I want to interview some of those people to generate better hypotheses so that I can design my experiment to go measure those people in that environment, right? So Lee's experiment, and I'll pick on Lee only because I know a lot more about him. He's been interacting a lot. So the experiment where you give out a free meal to come try out your product, right, has an inducement effect, right? Who won't sign up for a free meal, right? So how interested are people in your product from that? Well, how interested were they in a free meal, right? But if your goal is to measure something else, not their level of interest, but for example, their feedback on how they like the user interface, right? Other than the fact that you got to buy a sample because you chose people who were willing to come for a free meal, those people who are willing to come for a free meal may be way more representative of a subgroup of your sample. So you have a very biased sample because these are people that might care about money to the point where I will give up an hour of my time for a free meal. Now, if your customer segment is aimed at luxury products, that's not a very good way of measuring them, right? If your customer segment is aimed at people for whom money is an issue, then that's a good way of measuring it. And there's no answer to that. That depends on what your hypothesis and what you wanted to try and measure. So you really want to make that work out. Another common thing that I experienced in our second company was having experiments where there was a better experience in the experiment than in the actual product. So we actually had in-person help that we knew would never scale when we first launched our product. And there was lots of things we wanted to do in terms of learning that for which that was helpful. Every time there was a problem, literally they were calling me. I was the CTO of the company, and I would get every support help call line in the first 2 months got routed to me. The great thing is I could fix every problem. The bad thing is they were getting a much better experience than the original product have, because I would say 85% of all those problems were user error, right? They weren't the problem with the product, but users simply weren't going through the manuals. They weren't figuring out what's going on. And so in the long run, we had a difficulty as we tried to scale up the product, because we had not invested enough time in understanding the user's misunderstandings, because our experiments said that they really loved the product and everything was going well. But that's because we designed a bad experiment. Another really common one, more so for early stage companies that haven't really gotten far, but as soon as you have investors or start talking to people, this becomes a little less of an issue, which is improper comparisons. Some of this can be literal statements. Oh, we have no competition. Every time a student says that in the freshman class, I want to throw something at them. It's like, there's always competition. Anything else that your dollar can go to is competition. The question is, what's the closest thing? And then the other is improper comparisons that make people think something different about your product, but through bad analogies. Where the Airbnb of the bicycle rental market, right? They're not really comparable things. So those kind of analogies get people to think something wrong about your product, which then messes up your experiments completely, because they're thinking your product is doing something other than what you thought it was. This is all related in the sort of this communication piece. So how are you doing it? Another one that's common is unrealistically priced prices or properties, either an implied quality that can't be reached or a price point that can't be reached. And this is, again, if you want to feel good, tell people our product will be free, right? But that doesn't make you any money, right? So you got to figure out what that balance is, and figure out what your experiment is and how you're communicating price. Early experiments may not communicate price at all, but they may imply quality, right? So you have to be careful how that's affecting your experiments. And then the last one is not really an experimental failure. So I put it at the end, even though I might say it's actually the most common problem I see, which is selectively ignoring the actual data, discounting negative feedback, looking at the data and saying, oh, that doesn't apply to us, or selectively filtering the data by going through and saying, here's the data I want to pull out of what I have, not measuring new stuff. So those cause all kinds of problems as you're iterating through your hypotheses. So as you go through your experiments, keep these things in mind. Think about, I want to make sure I'm not doing this. And again, you all are in different spaces, so it's not easy for me to have an example that can go through everything. But as a mentor, you can reach out to me and we can talk about, for a particular example, how you might go through this for one of your hypotheses or multiple of your hypotheses. So you need to analyze the data from these experiments. I like to actually do stuff very quickly, but also try and be as formal as possible. So attribution of outcomes, if you design the experiments well, it's actually pretty easy to relate them. Early on non-experiments like interviews might allow us to draw all kinds of conclusions. Then I can come up with something and you can do a formal test. Things like formal t-tests are very straightforward to do. It's literally a function in Excel. So if you get a bunch of data that's well designed in terms of answering a question, you can answer, is this statistically significant or not? And then use that to make your decision. So hopefully you've got somebody in your team who's done statistics in some class before, but if not, you can literally just Google like how to test the hypothesis using a t-test in Excel, and you'll find various places. The hard part is not how to use Excel. The hard part is how to formulate the hypothesis, which is always about your business, so it's only you can answer those questions. So many experiments don't actually support a real conclusion in terms of a hypothesis, but it's easy to misuse that data to draw a desired conclusion. As I said, that's a common thing I see, people wanting to reach a conclusion, either because they feel this will get them money, they'll get them their grade, it's a self-induced decision of where they want to go. That's probably the most important thing, to try and keep yourself honest with yourself. Even if you're telling investors something else, you should always be saying, well, here's the other ways I could explain that same result, and then design something, design a new move, experiment, or a pivot if you decide you have to change things. But you really want to keep testing those hypotheses. And this is coming back to the question of falsifiability, right? When I said the reason that not A is not the same as A is because there might be lots of choices for A besides true and false. And so not A doesn't always get me where I want to be. I want to think about how the data might have these other explanations. And if you can imagine other explanations, you can decide they're far-fetched. Once you've made them and put those hypotheses down, you can say, you know what, that's such a small chance. It's not a very high risk. We're not even going to test that hypothesis. But stating it helps you put it in context. And sometimes you might state something, as I finally did when we were dealing with our second company, which was our company simply did not have the clout to change the government's view on certain problems, that our only solution was to sell the technology to somebody who's bigger and has lobbyists and can make it happen, because we were just never going to do that. We either licensed it or sold it, right? But we just, after enough experiments, figuring out what's going to go on, we realized that the government didn't want privacy in the biometrics. And so we were struggling in a battle. We just didn't have the resources to win. So we had to move in a completely different direction. But if you believe in your vision, you need to understand the limits of your experiments and then design another move, which is really what I just went through. I really believed in the vision of the product I was building. And I knew that there were definitely consumer subgroups of customers that would really care. Lots of customers didn't care, but as long as it worked, they were fine with it. They didn't need the added features. So I kept working on it. And as I said, by the time I was done, I spent more than $1 million building a product that we then sold off for, I don't know, $250,000. And so it was not a good investment of my time. It took me a long time to learn about all those pieces. So not all viability is about customers. Some are about engineering, others about costs and competitive advantages. You can design a move for any one of them. Some of the most expensive ones, and this is literally where Eric Ries was coming from when he started with MVP, were actually about engineering questions and the balance between engineering customers and customer wants and needs, right? Figuring that out is a much more complicated experiment, because if it's going to cost you $100,000 to test the experiment, that's a big experiment to run. It's got to have a lot of payoff to decide that it's worth it. And the competitive advantage is a category of things that people often fail to get to in testing. They don't want to test what is our unique selling point, what is our customer advantage. So if I look at the types of hypotheses we can do, right, there's sort of persona. Who is my customer? What do they like? What do they do? There are problem hypotheses. What really is the problem, right? Sometimes we don't even know exactly what the problem is. I struggle a lot with Troff's original problem because it's not one I see personally, right? So, but they were doing problem hypothesis testing and showing that people did care about that problem. The value hypothesis, even if the problem's there, if it's not an important enough problem, if it's more of a headache compared to a migraine, then maybe people won't pay much for the solution. I'll pay for an aspirin, but I'm not going to pay $100 for an aspirin because I can just live with a headache. So that the problem's scope is important. And then there's a whole bunch of hypotheses you can have about how do I reach my customers? How am I going to get and keep them? How am I going to retain them? Those are all important questions. And those are 4 very different categories. And each hypothesis needs an experiment, but they're not necessarily independent experiments. You can formulate a falsifiable hypothesis that requires you to identify a metric and use it to measure success or failure. But if from the same amount of data, I can measure 2 questions, very often the problem and value hypotheses are coupled. Is it a problem, and what's the value of solving that problem, are often extremely tightly coupled. Persona, who is my customer, and how do I create the customers or reach the customers and keep the customers, those 2 are often extremely coupled. So you can often design experiments that let you test multiple hypotheses at the same time. But you have to be careful. If I design a hypothesis that is A and B, and then I negate, especially if I negate it, then I get it's not A or not B, I run into problems because the knots and ors caused me to not be sure what caused my experiment to fail. So you do want to try and get a measurement that is about A and another measurement that is about B. And then you can talk about the combinations in any way you want. But if the only thing you can measure is A and B, then you have to be very careful because you don't know what's causing it to fail. Is it A or B when it's failing?
Hey, I've got a question for you.
Sure. Yeah.
This is from one of the teams. They're asking you if you can offer some insight into the sales process of finding somebody bigger, a bigger client or customer. And Sean, feel free to expand on this question.
Yeah, the expounding would be when you were talking about the problem of getting into an audience and you weren't big enough. So then your shift ended up being find somebody bigger than you to buy you. If you can take a couple of minutes, 120 seconds or so, and just kind of expound upon that a little bit, that is something. That's something I would find exceptionally interesting.
So that's a pretty different topic, which is like, how do I find a buyer? Basically, I changed my customer segment, right? Which is my hypothesis, right? My hypothesis was I could sell directly to customers, only to find out that was failing. And it was failing because there were people who would keep the product from being installed. And they weren't the buyers and they weren't the users, right? In my case, it was a government regulation group that would effectively decide what was and wasn't needed. So after I reached the hypothesis that the only way or a way, not necessarily the only way, but my hypothesis was a way to solve this was to change my customer segment and to try and look at large players in the space. So then what I did is I analyzed all of the different players in the market. So we did a very deep dive into the top 10 providers in our space and looked at them and analyzed what were they saying in their literature in terms of their outward facing statements. And then also, how much do they need an innovation that might give them a competitive edge? It is really hard to sell to the biggest player because they rarely need you, right? Whereas the second or third tier players are often looking at a way to gain a competitive advantage. And the same advantage I would describe to my customer, my end user, I can describe to that company. And that really was sitting down and then doing meetings with them. So testing the hypothesis in this case really came down to, well, there were two parts. One is we had a hypothesis that they would care about the problem of privacy and security in the way that we were describing it. And that hypothesis was, we basically sat down and we had meetings with them and we asked them questions about why they were doing certain things and why they weren't doing them. And when the interviews showed that they didn't see how to technologically solve that problem, but they would be interested in a solution, only then did we start talking about what our solution was. Because then we saw that they had the problem. We didn't want to put the solution out at first because we learned from other customers the first time is that if I try and sell them the solution, they find flaws with it because they haven't seen the problem, right? So our real question was a problem hypothesis. And if these customers don't see it as a problem, then you can't sell it to them, no matter what you want to do, right? So if you solve their problem, then you have a potential to sales. If you don't see that, so you want to design a series of questions, and some of the hypotheses were looking at what their own customer feedback had told them, right? And so that was useful, right? We could actually draw data from, for example, the online posts about their company, right? Which we then use to drive a hypothesis, which companies to spend our time on. So we didn't spend our time on the three, even though 2 and 3 might be the ones you think are the most interested in. It was true, it was clear from their customer feedback and their online presence, they really weren't interested in this product. They wouldn't be, because they view their primary customer as the government, and the government is the one who, so our product was basically providing privacy in a way that would keep the government from finding you at certain times. And there's lots of people in the government who don't want that. They want to find you whenever they want to. And so we had to find a customer whose data suggested that might be of interest to them. So does that answer it?
Yeah, that's very helpful. Thank you.
So I don't want to go too long. So I'm going to guess you've all seen the business model canvas. Okay. So how many of you have seen this one? Because this actually isn't the business model canvas. It looks the same. This is actually what's called the lean canvas. So it's a variation of the business model canvas. This is the actual business model canvas. It has things like key partnerships, resources, activities. The idea of the lean canvas is actually to replace a few of those and make it a little bit easier, I think, for many startups to focus on what they really should, which is first and foremost, What is the real problem I'm solving? Yes, I might have partners and whatever. Those are all nice things, but if I don't really know what the problem is, right, I'm not going anywhere. So I have to have hypotheses about my problem. And then I have my solution. And oddly enough, every time when the problem changes a little bit, my solution has to change a little bit. So these become coupled. One of the key things that I put in here, more is actually not from me, it's from the, I can't remember the guy's name, but Lean Canvas Group, is resources are great, but more important are metrics. What am I measuring and how am I using those to measure my progress? Okay, and actually every cell will have its own metric, but the key metrics are sort of the things that combine them together into a very simple overall measure. And so if you're in certain spaces, things like the Net Promoter Score is a great way of aggregating what your customers think about you. That might be one of your metrics, right? But it could also be a metric that is all about margins. We'll come back to that in a second, right? So it depends what metrics you want to measure in your business space. Value proposition is the same. The other one that has changed in the Lean Canvas, and I think this is very important for lots of startups, is to focus on your unfair advantage and to test hypotheses about what is our unfair advantage. Because a lot of companies get stuck in this problem of they have a value proposition, but the value proposition doesn't actually differentiate them from their competition. So if I go to test hypotheses about, do customers want hamburgers? I guarantee you their answer will be, there's a market for hamburgers. But that doesn't mean I should start a hamburger restaurant because I don't know what my advantage is over all the other customer things, right? So value propositions, if they're done right, would be a unique value proposition. But a better way to get many companies to think about that is to think about what's their unfair advantage. Because in fact, it may not be that the value proposition is unique. If I have a patent, I might have an unfair advantage because no one else can do it, right? I can stop them, right? If I have the money to do them. That was the other problem we ran into with our technology is if somebody ripped us off, we couldn't afford to fight them, even though we had a patent, right? So you got to find that balance. So this is a slightly better way of looking at that. And one of the ways that this becomes interesting is it allows me to now look at hypotheses from a slightly different point of view. There's the founder's worldview. We have this awesome solution to our problem. And that was part of what Zuckerberg wanted to do. And there are definitely companies for which it's the awesome solution that drives everything. If you get enough customers around an awesome solution, you can eventually make money. But it may take a long time to get there. And you have to worry that other people who have other awesome solutions might beat you. The people at MySpace thought they had an awesome solution too, if you're old enough to know what MySpace was, right? Zuckerberg killed them off, right? Their awesome was more awesomer. Customers are very important, right? They're going to look at your unique value proposition, your customer segments, and your revenue price, right? And they're going to look at those things and they might identify that. So those are hypotheses related to your customers. And then there are actually hypotheses that are, in my view, tied to your investor. What are your key metrics, your traction? How are you doing with respect to those? Your defensibility, how do we defend ourselves? What is the market size and what are our margins, right? All of these are hypotheses, but different people care about different hypotheses. And so you not only want to design your hypothesis to answer a question, but you have to look at the question from that person's point of view, right? So even though there's two questions about the customer segment, customer identity and customer and market size, those are two different hypotheses intended for two different audiences as you test the hypothesis. So as you iterate through them, you have to figure out who am I trying to show this to, which might affect literally how I want to phrase it and how strongly I need to measure it. If I'm measuring customer attraction by how many people are buying my product, I'm doing great. If I'm measuring customer attraction by how many people did I get to sign up, lots of investors will turn around and it's like, well, how many of those have actually committed to anything, right? Besides giving you a fake email address. You got to understand what those questions will be and think about your hypotheses from that point of view. And I think, actually, given the time, that the rest are just sort of some follow-up things. So I do want to come back to this one thing about vision. It's really important to understand the value of experimentation, but to not let it override your vision. Right? As Henry Ford once said, right, if he'd asked people what they wanted, they would have said faster horses. Right? You have a vision that might change the world, that is a very different product. You've got to keep refining your hypothesis and testing it, but not necessarily give up your vision. So if I think about pivoting, which you all heard a lot about, right? I start with some point. My goal might be that as I get to the valley of despair and I find out I can't go there, right? I might want to turn and go some other direction. And as I pivot, I'm going to go through a sequence of points. And I can, based on the data, I might have a giant pivot, and I can literally change the business model, the strategy. And what happened in my second company is they actually changed businesses 3 times before we built our product, right? Because they knew they wanted to be in the security space. The company was formed on September 12th, right? 2001, right? The day after 9/11. They knew security was going to be transformed in this country. They formed the company, and then they tried to figure out what the product was going to be, right? Once I joined, right, we had a grand vision in terms of things. And then after that, we just did minor pivots, keeping in mind that we wanted to reach our goal, right? But that grand vision, sometimes the best answer is like do a completely different business, right? So killing businesses is not the same as a pivot. In my view, a pivot is keeping your eye on the main vision and then changing how your path to get there, as opposed to changing what the vision is. Right? And there's nothing wrong with changing your vision. Then it's not a pivot anymore. That's a restart. And the most important thing I've learned from people who have to pivot is when you pivot, don't reuse your old data, which made you decide I was going to go in a new direction, and say it's now justified. You have to go out and regather it again, gather new data to support your new hypothesis. Because otherwise, which we saw in my second company, was after we pivoted, we thought we really had this thing going down, but we were deluding ourselves by doing bad experiments that were just reinforcing our belief. And yeah, we did okay, but we could have done much better. One of our competition destroyed us because they learned that the real question was not about security, but about generating reports for insurance. And we never got to that hypothesis. So we ended up getting dominated by them in the market and sold for a fraction of what they did. So hopefully this has been helpful. I know I went a little bit long, but are there questions that we want to answer right now, or?